Hey everyone. So today we're going to talk about the past paper for the February-March 2025 9709 CIE Mathematics paper 3 variant 3-2. So this is for the exam that's going to be on 19th May. So this is for that practice. All right, solve the equation ln 1 minus e raised to power 2x plus 3 equals to 0. So this is very straightforward. There are two ways to handle this, and if you go back to our videos, we talked about those two methods also. So one way is to make the 3 and 0 in terms of ln. So we write 3 as 3 ln e and 0 as ln 1. The other method is to take minus 3 on the other side. So ln 1 minus e raised to power minus 2x equals to minus 3. Now, when we simplify both of these, we will get the same expression. So let's see. So this remains as it is, minus 2x. This becomes ln e cubed, and let's keep ln 1 as it is. And now we can bring these two summands together using the laws of logarithm. So ln 1 minus e raised to power minus 2x e cubed equals to ln 1. So now ln is equals to ln, so we can equate the arguments now. That 1 minus e raised to power minus 2x times by e raised to power 3 equals to 1. Now let's see in the second side, on the right hand side, whether we get the same thing or similar thing at least or not. So over here, all we have to do is to take e raised to power to reverse the ln. This becomes 1 minus e raised to power minus 2x and then e raised to power minus 3. And as you can notice, these two are identical with one slight change, that when you do this thing, when you take e cubed on the other side, it becomes e raised to power minus 3. So now these two are identical to each other. So whichever way you start out with, does not matter as long as you know what you're doing. Now that we have this form, now we need to solve for x. So e raised to power minus 2x, that would be 1 minus e raised to power minus 3. Now, since this is an exponential equation, we take ln on both sides. So ln of e raised to power minus 2x equals to ln of 1 minus e raised to power minus 3. So minus 2x comes over here. This remains as it is. We don't need to do anything to that. And x would be minus 1 over 2 ln 1 minus e raised to power minus 3. So minus 3. And that's it. We don't need to do anything else over here. So now let's see what form question asked to 4 decimal places. So we will actually have to put this in the calculator. So minus 0.5 times by ln 1 minus e raised to power minus 3. This is, we need 4 decimal places. So 0, 2, 5, and 5. 4 decimal places. So this is the final answer. All right, so let's move it on to the next question. The equation of the curve is xy squared plus ln x plus 2y equals to 1. Find the gradient of the curve where x is equal to 0. So first off, we need to find out the y coordinate also. So y where x equals to 0. So we plug x is equal to 0 over here. So 0 plus ln 0 plus 2y equals to 1. So ln of 2y equals to 1, which means that you have this case. So 2y equals to e, and y is e by 2, right? So the coordinate that we are looking for, x is equal to 0, y equals to e by 2. All right, now we need to take the d by dx. So d by dx of x y squared will require product rule. This will require product rule, not product rule, but chain rule, sorry, equals to 1. Sorry, d by dx of 1. So using the product rule over here, implicit differentiation, so x times by derivative of y squared, so that is going to be 2y dy by dx plus y squared plus ln derivative, the argument comes over here, times by the derivative of the argument, which is going to be 1 plus 2 dy by dx equals to derivative of 1, which is 0. Now, one thing to remember over here, we just need the gradient of the curve dy by dx. So we don't actually need the expression for dy by dx. So, plug in x is equal to 0, y equals to e by 2. So we get this this entire term would be 0 plus y squared is e squared over 4 plus 0 plus 2y, so 1 plus 0 plus e times by 1 plus 2 dy by dx equals to 0. Now we rearrange and make dy by dx the subject. So minus e squared over 4 goes on the other side. So we have 1 over e, 1 plus 2 dy by dx equals to minus e squared over 4. E again goes on the other side, makes it minus e cubed. So 1 plus 2 dy by dx equals to minus e cubed over 4. Now we take 1 on the other side and finally divide by 2. So 1 over 2 minus 1 minus e cubed over 4. Since they haven't specified in what form we should leave in, so let's do the exact form. So what we can do over here, both terms are negative, so we can bring the minus out. Furthermore, we can take a common denominator inside the bracket. So this would be 1 over, sorry, minus, oh, sorry, let's do it over here. Minus 1 over 2, 4 plus e cubed, 2 and 4 multiplied, we get minus 1 over 8, 4 plus e cubed. That's your final answer. So gradient at x is equal to 0 is minus 1 over 8, 4 plus e cubed. All right, moving on to the next question. The shaded region on the Argand diagram shows points representing complex numbers defined by two inequalities. The shaded region is bounded by a circle. So bounded by a circle and a line parallel to the real axis. The boundaries of the region are included in the shaded region. Find the two inequalities in terms of z that define the shaded region. So this is straightforward. The imaginary part is less than -1, and we need to have a complex number representation of this circle. So this is easy. We need the center point, which is -2 and I. So z minus -2 plus I, and the radius is 3 units. So less than equal to 3, and imaginary part of z is less than equal to -1. That's it. You could, however, rewrite it in this form also, so z plus 2 minus I less than equal to 3. Find the greatest value of mod z for the points in this region. So basically, just like we have this as a starting point, this as a starting point, mod z means the distance from the origin. So we just need to see over here where is the uh, furthest point from the origin, and you would realize quickly that it is this point over here, which is this point of intersection over here. So this one. So we need to figure out how to find out. So -1 is the y coordinate of this. We need to figure out what the x coordinate is also. So for that, we can use the circle equation and equate it with the y is equal to -1 simply. So circle equation, we have -2 comma 1 as the point. So that would be x plus 2 whole squared plus y minus 1 whole squared equals to 3 squared, which is 9. So when we plug in y equals to -1, so this becomes x plus 2 whole squared plus -2 whole squared equals to 9. X plus 2 whole squared is x squared plus 4x plus 4 equals to, oh wait, sorry, we did not need that. We did not need that. Okay. So let's keep it as it is. X plus 2 whole squared equals to 9 minus 4, which is 5. Now when we take the square root on both sides, we will get plus minus root 5. Now that means we have either -2 minus root 5 or -2 plus root 5. Now we need the negative number to be in between -4 and -5. -2 minus root 5, as you can see, it's in between that. So this is the answer that we're looking for. So therefore, z is going to be -2 minus root 5 minus I. Okay, so this is the complex number. So therefore, we need the mod now. So first let's go with the square. So you have -2 minus root 5 whole squared plus -1 whole squared. Sorry, let's do this over here. So let's make a line over here. So let's use a different color for this. Okay. Now z whole squared equals to, this thing becomes 4 plus 4 root 5 plus 5 plus 1, and that's 10 plus 4 root 5. So mod z would be the square root of this entire thing. So 10 plus 4 root 5 whole square root. Now, again, they have not given us any specific form to leave it in, so we can leave it in the exact form. All right, so moving on to the next question. By first expressing the equation tan x minus 60 to cot x as a quadratic equation, in tan x, solve the equation for 0 to 0 less than x to 180. So we have to use the angle addition formula over here. So tan x minus 60 equals to 2 over tan x. So tan x minus 60 becomes tan x minus tan of 60 divided by 1 plus tan x tan of 60 equals to 2 tan x. This becomes, we know tan 60 is root 3. So this becomes tan x minus root 3 divided by 1 plus root 3 tan x equals to 2 over tan x. Now we cross multiply 2 tan x, tan x squared, tan squared x minus root 3 tan of x equals to 2 plus 2 root 3 tan x. Now we bring everything on one side, make it a proper quadratic equation. So tan squared x minus 3 root 3 tan x minus 2 equal to 0. Now we equate for tan x. So tan x equals to, now minus b is just 3 root 3 plus minus b squared, 3 root 3 whole squared is basically 9 times by 3, which is 27. Minus 4ac becomes 4 times by 2 plus 8. The minus minus becomes plus, divided by 2. So 3 root 3 plus minus, this is root 35 divided by 2. Now, before we solve this further, we know from the cos diagram that for acute angles, tan is positive, but for these angles, for obtuse angles, tan is negative. So we need both of these answers, negative and positive. So x is equal to tan inverse of 3 root 3 plus root 35 over 2, and then x is equal to tan inverse of 3 root 3 minus 35, 2. So tan inverse 3 root 3 plus root 35 divided by 2. So first answer is 79.797, and the other answer minus 19. So obviously minus 19 means this one, where tan is also negative. So since we just wanted in this uh, second quadrant, we just added with 180 to get this answer over here. Or subtract minus 19.797 from 180 degrees. So plus 180, this gets us 160.2, and this can be rounded to 79.8. So these are the two values of x. All right, moving on. The square root of minus 4 plus 6 root 5 can be expressed in the Cartesian form x plus iy, where x and y are real and exact. By first forming a quartic equation in x or y, find the square roots of minus 4 plus 6 root 5 I in its Cartesian form. So first, what we do, we know that if the square roots exist as this, square can be exist also. So rather than taking a square root, we can express it as a square. So square of the square root. So this can be expanded into x squared plus 2xyi plus y squared I squared. However, we know that I squared is equal to minus 1, so this term will become negative. So this becomes x squared minus y squared plus 2xyi, and over here we have this. So these two sides are identical to each other. So the real part will be equal to the real part, imaginary part identical to the imaginary. So minus 4 equals to x squared minus y squared, and therefore 2xy equals to 6 root 5. The second equation can be made in terms of y or x. So 6 root 5 over 2y, which can be made into 3 root 5 over y. Now we substitute this x in the first equation. So minus 4 equals to x squared. Basically, we are squaring this thing. So 3 root 5 squared is 9 times by 5, 45. So 45 divided by y squared minus y squared. So now we multiply both sides by y squared. This becomes minus 4y squared equals to 45 minus y raised to power 4. Taking everything on one side, we have y raised to power 4 minus 4y squared minus 45 equal to 0. Now, we can't solve it as it is, so we will solve it like a quadratic equation. So y squared will be equal to minus b plus minus b squared minus 4ac. So 4 times by 45 is 180, so plus 180 divided by 2. So square root of 16 or 196 is 14. So my plus 4 plus minus 14 divided by 2. So y squared is, so y squared would be minus, so 4 plus 14 divided by 2 is 18 divided by 2, 9. And the other answer would be negative. So plus 4 minus 14. So minus 10 over 2 minus 5. So obviously this cannot exist. This, however, can result in plus and minus 3. So x, we said that that's 3 root 5 over y. So x is equal to 3 root 5 over 3 or 3 root 5 over minus 3. So in both cases, 3 get cancelled. However, we get 2 points. So root 5 plus 3i and minus root 5 minus 3i. So these are the square roots. All right, good. Moving forward. The variables x and theta satisfy the differential equation dx over d theta 1 over 5x plus 1 sine squared 2 theta. Okay, so we need to first separate the variables. For that, we need to deal with this first. So when we make the denominator same, we get x plus 5 over 5. So you have dx over d theta equals to x plus 5 over 5 sine squared 2 theta. So we separate the variables, so 5 over x plus 5 comes on this side equals to sine squared 2 theta d theta. So we integrate both sides. The left side is simple. We get the ln form. So 5 ln x plus 5 equals to deal with this, remember the power trigonometric power trigonometric expression integration video. I will put a link over this. For that, we convert it into double angle form. So sine squared x would be 1 over 2, 1 minus cos squared, sorry, cos 2x. So in this case, we have 2 theta, so the angle inside will become 4. So 1 over 2, 1 minus cos 4 theta d theta. So when we integrate, 1 over 2 remains outside. This becomes theta minus the integration of cosine is sine. So sine 4 theta divided by 4 because we have to divide by the derivative of 4 theta and plus c. Now, they said that when theta is equal to 0, x is equal to 5, theta is equal to 0, x is equal to 5. So this would become 5 ln 10, 5 plus 5 equals to half 0 minus 4's sine of 0 would also be 0 plus c. So c is basically 5 ln 10, which can be further reduced also. So 2 times by 5. Actually, we can leave it like this. So we need an expression for x. So we have ample space. Oh no, okay, that's the only space we have. Okay, all right. So we plug it back into this form. So therefore, no, sorry, we have 5 ln x plus 5 equals to half theta minus 1 over 4 sine 4 theta plus 5 ln 10. So we take 5 ln 10 on the other side. So 5 ln x plus 5 minus 5 ln 10 equals to, we can multiply the denominators over here and make it 4 theta minus sine 4 theta. And since we have a minus sign over here, we can multiply the 8 with 5 ln x plus 5 over 10 equals to 4 theta minus sine 4 theta. Now we can take 5 and 8 on the other side, so 40 we can divide by 40 on the other side. Right, now we reverse the ln, so this becomes x plus 5 over 10 equals to exponent 4 theta minus sine 4 theta divided by 40. So minus 5 and multiplied by 10. Sorry, we multiply the 10 first. So x plus 5 would be 10 exponent 4 theta minus sine 4 theta divided by 40. And then finally, therefore, x would be 10 exponent 4 theta minus sine 4 theta over 40 minus 5. So this would be the expression of x in terms of theta. All right, moving forward. The diagram shows the curve y is equal to x cubed times by cos 2x for 0 to pi by 4 of 1/4 of pi. Curve has a maximum point at M. Show that P satisfies this equation. So we have to take the dy by dx of this. So dy by dx, so we have to do the product rule over here. So u can be x cubed, v can be cos 2x, u prime is 3x squared, v prime, the derivative of cosine is minus sine, but times by 2 also, so minus 2 sine 2x. So dy by dx would be minus 2x cubed sine 2x plus 3x squared cos 2x. Right, okay. Now we put this equal to 0 since we are looking for a maximum point. So this becomes we can take out the x squared. So this becomes minus 2 minus 2x sine 2x plus 3 cos 2x equal to 0. So this will lead to a trivial solution, x is equal to 0, but this on the other hand leads us to 2x sine 2x equals to 3 cos 2x. Now that would mean that we have sine 2x over cos 2x equals to 3 by 2x. This becomes tan 2x equals to 3 by 2x. So x is equal to p. That would be tan 2p equals to 3 over 2p. Therefore, p would be half of tan inverse of 3 over 2p. Right, that was that. Show by calculation that 0. So the p lies between 0.5 and 0.7. Okay, so all we have to show is when we plug in p is equal to 0.5, we get some value, p is equal to 0.7. We just have to show the sign difference between. So P is equal to 0.5. No. Oh, no. Sorry, my bad. So P minus this half tan. So P minus half tan inverse of 3 by 2p. That is your function of p. Let's call it some function of p. We need this to be equal to 0. However, when we plug in 0.5, we get 0.5 minus half tan inverse of 2 times by 0.5, that is just 1. So 3 divided by 1 is that. So 0.5 minus 0.5 times by tan inverse, 3. Oh, sorry, this needs to be in radians. So minus 0.124522 f of 0.7. So 0.7 minus half tan inverse of 3 divided by 1.4. So 3 divided by 1.4, 0.7. This is 5, sorry. And that is 0.7. So we get 0.132915. So sign changes between p is equal to 0.5 and p is equal to 0.7. Therefore, root lies between 0.5 to p to 0.7. Now, use an iterative formula based on the equation in part A to calculate p correct to 3 decimal places. Give the result of each iteration to 5 decimal places. Okay, so we have Pn plus 1 iterative formula, half tan inverse of 3 by 2p. So starting with P1 equals to 0.5, P2 would be, so 0.5, so 0.5 times by tan inverse of 3 divided by 2 answer, we get 0.62452. Now P3 would be 0.58813, then 0.59856, P5, 0.59558, 0.59642, 596, 0.59617. And since, remember, we just need 3 decimal places, so after 3 decimal places it is starting to become constant. We just need one more value to confirm. So P8 is 0.596245. So therefore, P is equal to 0.596. All right, so that's the final question. All right. Two lines have equations this show that the lines are skew. So lines skew means they don't have the same direction vectors, but they don't meet either. So we make the parametric form. So minus 1 plus 2 lambda, 3 plus 3 lambda, minus 4 lambda equals to my 2 minus mu minus 3 minus 2 mu minus 1 plus mu. So we equate any two of these. So minus 1 plus 2 lambda equals to 2 minus mu. 3 plus 3 lambda equals to minus 3 minus 2 mu. So these two become 2 lambda plus mu. 2 plus 1, 3. Second one, 3 lambda plus 2 mu, 2 mu equals to minus 3 minus 3 minus 6. All right, so to solve this, let's multiply this by 2. So we get 4 lambda plus 2 mu equals to 6, and 3 lambda plus 2 mu equals to minus 6. So we subtract these t together, so minus minus plus. This cancels out, so lambda is equal to 12. And if lambda is equal to 12, so therefore mu would be 3 minus 2 lambda. So 3 minus 2, 12. This becomes 3 minus 24, so minus 21. So we plug these two values in the third equation, this one, and see if this is correct or not, they satisfy or not. Plugging in third equation, so minus 4 lambda equals to minus 1 plus minus 21. So minus 4 minus 48, that is minus 52, and that is minus 22, so obviously not satisfied. Therefore, lines do not intersect, and are skew. All right. Find the obtuse angle between the directions of the two lines. Okay. So 2, 3 minus 1 and minus first. 2, 3 minus 1 dot product, and minus 1 minus 2 and 1. So basically we are taking the dot product over here, or the scalar product over here. So square root of 2 squared plus 3 squared plus 1 times by 1 plus 2 squared plus 1 times by cos of theta. So in dot product, we know that the component by components, they multiply and then add up. So minus 2 minus 6 minus 1 equals to 4 plus 9 plus 1. Actually, I think we can leave it like that. Root 14 times by root 6 times by cos of theta. So cos of theta is equal to um, minus 9 over 14 times by 6, that is 84. So theta would be cos inverse of minus 9 divided by square root of 84. We get degrees, 169.1 degrees. That's it. All right, moving on. The polynomial 6x cubed plus ax squared plus bx plus 9 is denoted by p of x, where a and b are constants. It is given that x minus 3 is a factor of px, and when the first derivative p dash x is divided by x minus 3, the remainder is 72. All right, so we have two things. We need the derivative also. So first we do the d by dx of 6x cubed plus ax squared plus bx plus 9. So 18x squared plus 2ax plus b. All right, so we go for p of x is equal to 6x cubed plus ax squared plus bx plus 9. So we x minus 3. So p of 3 is a factor. So that means when we plug in this would be equal to 0. So 6, 3 cubed plus a, 3 squared plus b, 3 plus 9. So 6 times by 3 cubed plus 9, that is 171, plus 9a squared plus 3b equals to 0. Sorry, 9a plus 3b. So 9a plus 3b equals to minus 171. So that's equation number 1. We need to find the second equation that's going to come from this. So, right. So now p dash of 3, which is this function, so 18x squared plus 2a 3 plus b equals to 72, because the remainder is 72. So 18 times by 9, that is 162. So 72. Oh, sorry, what was it? Oh, sorry. So 72 minus 18 times by 9, that is minus 90. So that means 6a plus b equals to minus 90. So that is the second equation. So we combine these two. So, oh wait, what we can do is we can times this by 3, making it into 18a plus 3b, and then minus 270 also 2. So 18a plus 3b equals to minus 270, and then we have 9a plus 3b equals to minus 171. We subtract these two equations together, we get 9a equals to minus 270 plus 171. minus 99. So A is minus 11, and B we had from, oh, sorry, this one. So B will have minus 90 minus 6 times by minus 11. So 6 times by A. So minus 90 and plus 66. So 24. Minus 24. So A is minus 11. B is minus 24. Okay, moving on. When A and B have the values found in part A, factorize P of X completely. So, all right, so this is a cubic equation. We have one factor. Okay. So we can do the long division over here, and then we can further factorize. So 6, so wait, we x minus 3, sorry, not square root, division, 6 x cubed minus 11 x squared, and b was, okay, minus 24 x, and the last thing was 9. Right, okay, so we do the long division over here. So first we need 6x squared, so this becomes 6x cubed and minus 18x squared. So minus plus, this cancels out. So 18 minus 11 is basically 7. So 7x squared minus 24x. Okay, now we need the 7. So plus 7x. So 7x squared, and 7 times by 3, 21. So minus plus, this cancels out, leaving us with 3x plus 9. So simply we have, wait. Is it minus 9 or plus 9? Oh, sorry, this is negative. Okay, this is negative. So we multiply this by minus 3, we get minus 3x and plus 9. So obviously this is over. So 6x cubed minus 11x squared minus 24x plus 9 is identical to x minus 3, and 6x squared plus 7x minus 3. So we need to further factorize this. So 6x, sorry. So 6x squared minus 3, 7x. So 3 only comes one way, and 6, however, can come different ways. So maybe 2 and 3. So 9 minus 2, yes. So 9x, 2x minus 2. So this one is negative. So therefore, this becomes x minus 3, 2x plus 3, and 3x minus 1. Right. Hence, solve the inequality p of x less than 0. All right. So remember the cubic equations we made, and we learned how to sketch them. So these represent our roots basically. So x is equal to plus 3 Oh, sorry, no. So let's go a little bit further. 3, and then you have 1 over 3 also, and then minus 3 over 2. So this is, the coefficient was plus, so this would go this way. So the sketch is basically this way. So one region where it's in between this is this, and the other is this. So that's all we actually need to show over here. So, so x minus 3, 2x plus 3, 3x minus 1 less than 0. So we get x less than minus 3 by 2, or x is between 1 over 3 and 3. That's it. That's it. All right. Question number 10. Let f of x is equal to this. Express f of x in partial fractions. So over here we have a quadratic uh, expression over here which we cannot factorize. So we will have minus 7x squared plus 2x minus 6 over 1 plus x, 4 plus x squared, a over 1 plus x, and then bx plus c, 4 plus x squared. So basically that means minus 7x squared plus 2x minus 6, identical to a times by 4 plus x squared, plus 1 plus x times by bx plus c. Now, we have three unknowns over here, so we can plug in any values of x, any values that can help us. So first off, we can go with x is equal to minus 1. So minus 7, minus 2, minus 6, 4 plus 1, 5. This term would become 0. So minus 9 minus 6 is minus 15. A 5. So A is minus 3. Now, for the other two, we can plug in 0 first. So we get minus 6, identical to A times by 4. So basically A, we have minus 3 now. So minus 3 times by 4. 1 plus 0 is just 1, and then 0 plus c is just c. So minus 6 plus 12 equals to c. Therefore, c is equal to 6. Now, for the b, any value we can take. So 1. So minus 7 plus 2 minus 6. A is minus 3. So minus 3 times by 5 plus 1 plus 1, 2. B plus C. So minus 7 plus 2 minus 6, that is minus 11, plus 15 equals to 2. Oh, sorry, B is 6, C is 6. So 2B plus 12. So minus 11 plus 15 minus 12 is minus 8. Therefore, B is minus 4. So we get A is minus 3 over 1 plus x, and b is this, so 6 minus 4x over, what was it? Yeah, so 4 plus x squared. All right. This is equal to f of x, sorry, f of x. Okay. Hence, find the exact value of limit 0 to 2 f of x. Give your answer in the form a pi minus ln b. All right. So that means we are integrating these things. So, oh, no. So this basically. This will be handled with ln. This will be handled with tan inverse. And also we will need to split it also. So we have minus 3 1 plus x dx plus 6 over 4 plus x squared, and then we have, sorry, so dx plus minus 4x over 4 plus x squared dx. So what we can do over here, since we have 0 to 2, we can write 0 to 2, 0 to 2, 0 to 2. And what we can do is we can solve them separately because okay, we don't have a lot of space. All right. So, right. So for the first one, you have minus 3. So minus 3, 1 plus x dx, 0 to 2, that is just simply minus 3 ln 1 plus x, 0 to 2, which means that this is minus 3 ln 1 plus 2 minus minus 3 ln 1 plus 0. So ln 1 is just 0. The second term goes to 0. Oh, sorry. So this second term goes to 0. We are left with minus 3 ln 3. All right, for the second one, actually the fourth one first. So minus 4x, 4 plus x squared. So as you can see, 4 minus 4 over here has nothing to do over here. So we can bring minus 4 out. So minus 4 we can take out. So the derivative of this is 2x. So 2 over here divided by 2 over here. So this becomes minus 2 ln 4 plus x squared from 0 to 2. Let's solve this. So minus 2 ln 4 plus 2, 4 plus 4, and minus 2 ln 4 plus 0. So we get minus 2 ln 8 and plus 2 ln 4. So we get 2 ln 4 minus 2 ln 8. So 2 ln 4 over 8. So that is just 1 over 2. Right? And this can be written as just minus 2 ln 2. Right. Now, the third one. You have 6 can be taken out. You have 1 plus 4 plus x squared dx, which can be written as 4 can be taken outside also, and 6. So we are left with 1 plus 1 over 4 x squared dx. However, since we need 1 over 2 over here, so what we can do further is we can multiply this by 1 over 2 over here, and then 1 over 2 over here. That leaves us with, now we can do the tan form over here. So if you've forgotten the tan form, the derivative, sorry, d by dx of tan ax, we did this in differentiation videos, that was a over 1 plus a squared x squared. So that's why we're doing this. So this is, this turns out to be 6 divided by 0.5 divided by 4, that is just 3. Tan inverse. Now this is 1 over 4 x squared, so half of that, square root of that is 1 over 2 x. From 0 to 2, which can be written as 3 tan inverse of 1 minus 3 tan inverse of 0. So tan inverse of 0 is 0, but 3 tan inverse of 1 is pi by, tan inverse of 1 is pi by 4, basically. So 3 pi by 4. Right, now we add up all together. So f of x dx from 0 to 2, we get minus 3 ln 3 minus 2 ln 2 and then plus 3 pi by 4. So this becomes minus ln 3 cubed is 27. This becomes ln of 4 plus 3 pi by 4. And what form did they want us in? Okay, all right, this is already negative. So 27 and 4. Oh, sorry, no. So 108. So minus, 3 pi by 4 and minus ln 108. And that's your final answer. Okay. Find the exact value of 0 to pi x squared cos 1/3 of x. So we have 0 to pi of x squared cos of 1/3 of x dx. So we have to do this integration by parts over here. So you would be, so we have this I late rule over here. So algebraic will come first because they can disappear. So u is x squared, u prime would be just 2x. But if you have cos of v as cos of 1/3 x, we don't need v prime, instead we need integral v dx. So integral of cosine is sine. So sine 1/3 of x divided by 1 over 3, so that becomes 3 over here. Okay, so we know the integration by parts rule. So that is u integral v dx minus whole integral u prime integral v dx whole dx. So this is what we're going to do over here. So u times by that, so 3x squared sine 1/3 of x minus integral u prime, that is 2x, times by integral, so 2 times by 3, so that becomes 6 basically. 6x, so 3 times by 2x, sine 1/3 of x dx. So now as you can see this, that we have another, we need to take another step over here. So for that, let's do this over here on this side. So u is 6x, u prime would be just 6, v is sine 1/3 of x, so integral this time would be cosine negative, so minus cosine 1/3 of x, and again, since we're dividing by 1/3, it gets minus 3. So we will have 3x squared sine 1/3 of x minus 18x cos of 1/3 of x minus integral 6 18, sorry, minus 18. So minus 18 cos 1/3 of x dx. So this minus minus can become plus over here. So brackets. Now, finally, we simplify this and, oh, this was a definite integration, I forgot. So 3x squared sine of 1/3 of x minus minus becomes plus 18x cos 1/3 of x, and again you have integral of cosine, which is going to be sine. So 18 times by 3, 54 sine 1/3x from 0 to pi. All right, now we need to plug in the values. So 3 pi squared sine pi by 3 plus 18 pi cos pi by 3 plus 54 sine pi by 3 minus 0, 0, 54 times by 0, because that is 0. So that will also be 0. So that leads us to sine pi by 3 is under root 3/2. So pi divided by 3 and under root 3/2, yes. And cos pi by 3 is 1/2. So 3 under root 3/2 pi squared plus 9 pi, because 18 divided by 2, cos pi by 3 is 1 over 2. And then you have 54 sine pi by 3. Again, sine pi by 3 is under root 3 over 2. So 54 divided by 2 is 27. So 27 root 3. And that's it. So that's the final answer. All right, and that's the end of this paper. Hope you learned something. If you feel that I made a mistake somewhere, or would you, or if you'd like some clarification on some question, feel free to reach out in the comments, like, subscribe to our channel, and engage with us. Tell us what you liked about this video. All right, so see you in the next video.